Okay, this one might look a little scary at first, right? I've got a fraction with trig functions inside the fraction, and then square roots on the other side, and you know, all that. Try not to think about it being scary. Try to just go through the procedures that you understand from fractions and equations. And the number one rule with fractions and equations is get rid of the fractions. Multiply both sides by something that will cause the denominator to cancel out. So here's what I mean. We're going to write this down. Tangent omega minus 1 divided by tangent omega plus 1 equals this thing over here, 2 plus radical 3. Now, it's the denominator that's causing me trouble. That's what's blocking me from solving this. And if you want to multiply both sides by that denominator and cross it out, great. I think one way we've gone over this in class a lot is to multiply each side by a crazy 1 so that you have common denominators. And if you like that method, go for it. Okay, it'll basically look the same. You're going to get the same answer. So I'm going to multiply the right side by tangent omega plus 1 over tangent omega plus 1, right? That's just a crazy 1. It's not changing the value of the right side at all. And once I have both sides, see, this is one big fraction here now. Once I have both sides of the equation with the same denominator, you can just cross out all those denominators, which is equivalent to multiplying both sides by some value. In this case, tangent omega plus 1. So now what do we have? We have tangent omega we have tangent omega minus 1. Watch those minus signs. Equals this thing on the right. Now that might give you some pause, and it is perfectly fine to take your time when you're multiplying these sorts of things out so you don't make mistakes. And however you like to do that, whether you like to distribute the multiplication like I just did right here, or if you prefer doing foiling, right, first, outer, inner, last, if you like that method, that's fine. Either one works. So this is going to be 2 tangent omega plus 2 plus radical 3 tangent. Hope you don't mind seeing a radical in front of a trig function. That's going to happen from time to time. So I get all this stuff on the right. What's on the left? Tangent omega minus 1. So if we could group together all our common terms, like the tangents and the numbers and everything, that might get us somewhere, because right now this is looking kind of ugly. So I'm going to put all my tangents on the left and all my numbers on the right. So I'm going to add 1 to each side. Okay, and I'm going to subtract 2 tangents and subtract radical 3 tangent, that ugly thing, from both sides. Okay, so minus, all that. What do we get? We get tangent omega minus 2 tangent omega minus radical 3 tangent omega equals, well, I finished those things, so all that's left on the right side is 3 plus radical 3, right? 2 plus 1 makes 3, and then there's that radical 3 over on the end. So all I'm really doing is combining like terms, and we can still work on the left side here. Tangent minus 2 tangent is going to be negative 1 tangent omega minus radical 3 tangent omega equals 3 plus radical 3. And now what you're going to do is recognize that you have a GCF, a greatest common factor that you can pull out, called tangent. And what's left behind? Negative 1 minus radical 3. Okay? Equals, right side hasn't changed. And now that that GCF is out of there, you probably recognize what we need to do. I want tangent by itself on the left. So I'm going to divide each side by this thing. You can divide each side by something, no matter how ugly that something is, as long as you're doing it equally to both sides. So we cancel those out, and I just get this. Tangent omega equals 3 plus radical 3 over negative 1 minus radical 3. Okay? You know your unit circle, right? Do you recognize this thing? I wouldn't. We're going to need to work on this so that it looks more like something we're used to. And the first thing I look at with this thing is, see that denominator? That negative 1 minus radical 3? I want to rationalize this, see if we can maybe make it not as ugly. So I'm going to multiply top and bottom by the conjugate. Hope you remember how to do that. Negative 1 plus radical 3. Okay, remember the conjugate means you just take the same numbers and you flip the sign in between them. So -1 plus radical 3. Okay, well, let's work on what this is. On the top, and I'm just going to FOIL here. Okay. So I'm not going to show all the steps. I get -3. That's the first terms. The outer terms gives me plus radical 3. Ooh, plus radical 3 squared. Right? Oh, no. Plus 3 radical 3. And then minus radical 3. And then looks like a plus 3. Okay, so that's the top. The bottom is also going to FOIL. And that gives me 1. And then minus radical 3. And then plus radical 3. And then minus 3. Okay, so we simplify this some more. And you can see the -3 and the positive 3 cancel out on top. And the 3 radical 3 minus radical 3 is just 2 radical 3. And on the bottom, the radical 3's cancel out. So you just get 1 minus 3, which is -2. Okay, look at that. This thing just simplified way down to tangent equals negative radical 3. Okay, so let's write that again here. And I hope you have your unit circle memorized. If not, I have one right here. Negative radical 3. Where is that on the unit circle? Well, for tangents, that's over here. Okay, right there. And there's another one right over here. Okay, they're kind of the high numbers, almost towards the DNE on the y-axis, but not quite there yet. So the two angles there are the following. Omega equals, the one going clockwise, the first one is 2 pi over 3. The second one is 4 pi over 3. Okay, this one was kind of involved because it got into that ugly radical rationalization stuff. But the techniques that we use here, let's just review those real quick. If you have a fraction like this, first multiply by a denominator to get rid of the fraction. FOIL all your terms, combine like terms, okay, and then you win.